Alright, here I'm going to make a quick run through of different ways to power redstone mechanisms so that you can get an idea of how to make the various circuits work. So the first thing we've got is, this is a redstone lamp. It just lights up whenever there's power to it. So it's only for demonstrating that there's power or not power. First mechanism of powering, as I'm sure you know, is a switch. Switch can be in front of a lamp, it can be on the lamp, it can be below the lamp, and we're going to talk about how that works in just a minute. It can also be on a block above the lamp, which I'm going to talk about as well. Button, these are solid inputs, so this is essentially a continuous input until you turn off. Button gives you a period of time where there's a pulse, and it turns on, and it'll turn back off. Different buttons have different pulse lengths, so the wood button is longer than the stone button. I'm going to use the stone button from now on just because it's quicker. The button can be on, the button can be below, the button can be above. This would work if this block was below as well. Next mechanism of powering is redstone torches. So a redstone torch directly next to a block will power it, but it won't power subsequent blocks. We don't need these ones. A redstone torch connected through redstone dust will power both of these. A redstone torch connected to a block below will power the block above and the block behind, but it will not transmit that power through redstone. So if we come here, we've got this redstone torch, we've got redstone dust, a block, and then no power coming through it. This works uniquely because of the way the redstone lamps work. But this is called soft powering. So this block here is soft powered. So something directly connected to it will work, but anything that needs more redstone to go through is not going to actually be powered. All right, next one. This is a redstone repeater. So you have redstone torch, dust, repeater. And what a repeater does is it extends the length of the signal that's being put out. So the redstone torch can put out 15 blocks worth of power. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And then we put our lamp on the end and it'll light up. If we put a 16th and we put our lamp, whomp, doesn't light up. So this 16th one isn't powered. What a repeater will do is it will boost the strength back to a full 15. So now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and I can put my block and it will power. So this can be used indefinitely to make a circuit as long as you don't go so far that it won't render anymore. The other thing that a repeater can do is introduce a delay. So if we have a button and a repeater, we hit that, turns on, turns off. Put a piece of dust and then a light. We hit the button, turns on, turns off. We can have a 1 tick delay, 2, or 4, and it delays how long this takes to come off. Now the effect of this is really better seen when you have a bunch of these. So, and then lamp, and we hit the button, and a long delay before that goes on. So, coming back to our redstone system over here, the other unique thing about a repeater is that it will hard power any block that it's connected to. So whereas here, this redstone does soft powered this, meaning that the redstone on the other side doesn't get any power, this one, because of the repeater going to this block is now hard powered, which means not only things connected to the block will turn on, but redstone coming out of the block will also be powered and can be used to continue a circuit on. Redstone torch attached to a block will not power that block, so you can see there's no power going there. However, redstone torch under a block will directly power it, and you can see that it's a hard power because this is coming on here. So redstone torches connected to the block don't power that block. Redstone torches under a block will power that block, and you can see that extended here if we have a redstone torch on the side and I put a block over the top of this, then that block is hard powered. So you can use this idea to actually make power inverters. You can do this, or you can do this. So now I have a power inverter. So if I've got a power coming in here, this is on, this is off, I can add a button and briefly change the state of the system. This can be useful for generating a single pulse, but is not really all that relevant right now. So this is the comparator. Comparator has multiple functions and is one of the most annoying and yet potentially useful components in the entire game for redstone. What it does is its first function is to output a signal of the same strength as what you put in. So if I put in a signal strength of 15, I get all 15 lamps. If I back this up and put in a weaker signal strength because it's farther away, then I get the same signal strength that I put in, and you can see down here the last 2 lamps didn't get power. The next thing that a comparator can do is to compare 2 power sources. So if I have a side power source coming in, the system will look and say, and you can put it from either side or both sides. It'll say, is this back signal stronger than either of these ones, whichever one is stronger? If it is no, then there's no power output. If this is stronger than this, so I bring this out, that one's 1, 2, so I go 1, 2, 3, and put a power, it stays on. If I go equal, it stays on. If I go stronger, it turns off. So it can compare the power from 2 sides. The other mode that it has, you can click and it turns into a subtract mode. And what this does is it subtracts the strongest side from the back. So if I have 3 here, 1, 2, 3, and then so this is 15 and this is 14, 13, 12. I should end up with, sorry, this is 14 because I have 1 there, and this is 12. I should end up with 2 because 14 minus 12 is 2. So it subtracts the stronger pulse, the side pulse from the back pulse. I know that's confusing. Don't worry about subtraction mode. It's not really all that necessary. Much more immediate use for comparators. What are you doing, sheep? That's fair. Okay. Another use for comparators is they can measure the fullness or power output of a container. So I've got a comparator here and I've got the same lamp setup I had before. I put a block of nether wart or a stack of nether wart in this box, you can see 1 lamp lit up. If I put more, another lamp lit up. Now I have to keep putting more to get more lamps to light up, but it can measure the fullness level of this box. And that is useful in sorting items or in just in general telling how much stuff you have in a particular box. This is a horse. Horses are not redstone components. However, this is a hopper. Hoppers are redstone components. So hoppers, in their simplest form, purely take things from one place to another. So if I put a stack of nether wart in here, you'll see it filtering through the hopper and coming out in this box. Now, an important function of hoppers is that they can be locked. So if I power this hopper through this redstone, you can see that it's no longer filtering, or it's no longer moving these blocks from the top box to the bottom. So if I take this out, nothing else will flow into it. Hoppers will always check for a container or an item above them to see if they can pull something in before they'll push it out, which is going to be important when we build an item sorter. So hopper moves things from the bottom, or always up to down. They can also move things side to side. So if I have a, let's say a chest here, and a chest here, and a hopper that connects to this chest, the hoppers can only take things from the top if they're taken out of a box, but they can move them to the side. So I put this in here, and it moves over here. And I can actually do this with a whole train of hoppers. And it will move it from there through all the hoppers over to here. Okay, this is the basic unit for a sorting system. It's going to look really complicated, but I promise it's not at all complicated once we go through the individual components. So first we have a redstone torch, which is providing power to this repeater. This repeater is connected to a block, which means it's hard powered because it's directly going in, which means that this hopper, which is connected to that block, or adjacent to that block, is going to be locked. This means that nothing can go through it right now. Above, we have a comparator. The comparator has this hopper pointing into it, which means that it will read the output from this hopper, just like it read the output from that box down there to see how much is in it. Once this comparator reads 1, 2, 3 strength redstone signal, i.e. once there's enough stuff in this hopper to power this 1, 2, and 3 pieces of redstone dust, when this comes on, that will turn off this torch, which will turn off this repeater, which will unpower this block, which will unlock this hopper, allowing things to go through. This is useful for a storage system because it means that I can take an item that I don't want to sort, so some kind of, let's use these observers, and I can put them in the first 4 spots to block them off, which you can see starts putting out a redstone signal, but it's not enough to be able to turn this off. Now, as I start to put more items into this hopper, you'll see, let me see if I can get this so you can actually see the repeater, or the redstone torch. There we go. So there's this redstone torch right over here. That's what you're watching. So as I put items into this hopper, eventually I will hit a number of items that will turn off that redstone torch and allow these to go through. So 41 items, if you have one item in each of these, is what it would take to get this to go through. Now the reason this is useful is because as soon as it hits that 41, it drops back below the amount of power output necessary to turn this off, which locks this hopper again, which means that nothing more is going in there. So now, if I put another hopper on top of this, let's say I had a box here, and I have a train of hoppers that are going over the top of this. If I put nether wart into here, when it gets to this hopper, it's going to unlock the lower one, and it's going to end up in this box. But if I put something else in here, now it can't be the thing that I used as my sorter here. If I put this in, it's going to drop into these spots and it's going to mess everything up. So usually you want a unique named item in there that you would never want to sort. But if I put, say, redstone in here, that redstone is not going to be able to pass through here because all these spots are filled, which means it won't unlock this hopper, which means that it won't go in there. Instead, it's going to move on through, and I could move on through to the next module that sorts redstone, or in this case, it's just flowing through to the overflow box, and it's just coming through all these hoppers here. So this is the basic unit for the sorter system, and this can be tiled, meaning that you can build multiple of these right next to each other. And this one has to be glass. The reason for that is that glass doesn't actually transmit power. So whereas other blocks can be hard powered, as we looked at before, try to put all my redstone dust in that other box. Oh. Let me just wildly hit buttons here. There we go. Okay, so this can be hard powered, and this will go through. Glass cannot be hard powered. The reason this is important is that this torch is directly below this block, which means that this torch would actually power this block, hard power the block, which would then turn on this redstone, which would then come down and turn off this block. So you would create a short circuit, and this will just flicker and go out. So if I put a new torch here, flicker, 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 short out. So that's why that needs to be glass, so that that doesn't transmit power.